questions. Three.
Okay, have 2 minutes. How much I get you?
I mean, I guess I'm just confused because how I was graded, they took PAUB to be 800 over 4,300.
Yes, that's A union B. So A is about the attribute of like a riding bike, and so basically it's a bike. These are item sets. So that's the main thing. So we're basically saying whether bike and the ski would occur together, right? So A union B is the item set of biking and the item set of skiing. So A union B is about these two occurring together. So it's the item set.
Okay.
Yeah, that's just a notation thing. So the main thing is just like you want to show.
I guess my confusion is that this is the equation that was given.
Yeah.
And the problem that I'm having is that, like, in every other probability class.
Yeah, but this is not. Yeah, we're using item sets. So A and B are sets of items. So we're basically saying it's A union B. So it's the union of two item sets.
Okay. Okay.
You see what I mean? So that's because with with us all the probability class they're using the intersection, right? Yeah. Well, actually it's the two variables, but A and B are variables. But in our case, we're using this is in the concept of the item sets. So we're using A and B. Like for example, like if you're purchasing certain books, let's say, right? Yeah. So this is a set of books. This is a set of books. So we're talking about these books being purchased together. So that's the union of those two item sets.
Okay.
Yeah, but these are not variables.
Okay. I mean, I guess that makes sense.
Yeah. Okay. But yeah, we can talk more later. Okay. But I'll just All right, let's get started. So as you notice, the weather is changing very quickly. Hopefully Thursday is slightly better, but tomorrow is really bad. So everybody just stay warm, okay? And then get ready for the exam, okay? So first thing, I want to just make slight change of our schedule. So our original planning is that after midterm this week, we're going to have the checkpoint for next week, okay? So I've been talking about some of the groups. Looks like I think we'll probably all need a little bit more time to actually switch to the project once we're done with the midterm exam, okay? So what we're going to do is that, so next week, instead of doing the project checkpoint, we're going to postpone that for 1 more week, okay? So next week, we'll just continue with our lectures, okay? So after we're done with the midterm exam this Thursday, next week, 2 lectures, no more homework. We're done with the homework, so we're done with the midterm exam. But then next week is really when you want to kind of focus on your project so that you're ready for the following week when we're going to do the checkpoint. Okay, so just keep that in mind. We're going to send out the scheduling survey, just like what we did for the proposal. Okay, the plan is that to have the survey out by next Tuesday. So groups, please fill out the survey by Thursday so we can do the scheduling of the group meetings, okay, for the following week, okay? And then similar thing, right? So just like what we did in the proposal, we have the slides, we have the report. You don't need to do anything from scratch. Just take what you have, update it, right? Because the checkpoint, the main idea is just to see where things are, right, since the proposal. Okay, so we just want to make sure like all the projects are on track. If there are questions or issues, like we would like to discuss now rather than waiting till the end of the semester, right? So that's really the idea. So some of you are asking like how much you need to show for the checkpoint. I know like different projects, like they progress at different like paces. That's okay, right? So we're not like as concerned about check marks if you have done this, done that, right? But it's more about by now we want to make sure that you are on track to a successful finish, okay? So that's why I say if there are issues, we want to address them now rather than waiting, okay? So think about whether you have the data, whether you have started some preliminary analysis, so you kind of have better idea what you can do for the project, okay? So this is really just for a status check, okay? So keep that in mind. I know everybody right now is probably more in the mode of the midterm exam, so don't worry too much about that, but just knowing that you have 1 more week, okay, to focus on the project before we get ready for the checkpoint, okay? All right, so midterm exam, we are going to do this for this Thursday, okay? So all of you, right, just plan to either take it in person, right, if you're in person section or you're in the online section, but you'd like to take it in person, you can all do that, okay? Other ones, the Zoom sessions, either any special accommodations, we should have been either confirmed or in communication about like how we're going to set things up, okay? So if you haven't heard from us and you need anything, like as a Zoom or special accommodation, please contact us as soon as possible. We want to, of course, make sure like everybody's scheduled for, okay? So we can get this all done for this Thursday, okay? As a reminder, right, closed book exam, formulas will be provided, no coding, no calculator, okay? So you have seen this in the practice exam. Hopefully that gives you a better sense. Yes?
Is there partial credit on the exam, or is it just like you get it right away?
So the question is about whether there will be partial credit. Yes. So for actually all the questions, so like that's what it's important for you to show your steps, right? Even if like say there are pieces that may not be correct, but if you can see that we can show what you have done is correct, we'll give partial credits. Yes. Okay. So that's actually important to keep in mind because we have seen some in the homework questions, right? If you just give us an answer and that's not correct, sorry, right? We cannot give you anything. But if you have shown the steps, right? So that is how we can actually take that into account and give you credits for what you have shown to be correct. Okay? All right. So that's the exam. And another reminder about the office hour. Okay. So today's a Tuesday, right? So I had my first session there, but I have another one tomorrow. That's a Zoom only for the evening time, okay? We also have one more tomorrow afternoon, okay? So those are the office hours. You can come to us and ask any questions, okay? Just keep that in mind so that you can get your questions addressed before the midterm exam. Okay, now, moving on to the sample midterm exam. How many of you have you taken that as an exercise? Finish it? Okay, all right. So hopefully you have done it, okay? What do you think? Was it hard? Surprised? Or kind of, you kind of expect that those will be the kind of question you see? Hopefully, okay? So that's also like one thing I like kind of like reiterate, right? So as you kind of prepare for the midterm exam, go to the slides, right? The lecture slides is definitely a good kind of like outline, right? For you to see what has been covered in the review session with specific, these are the things we want you to understand. We had a few skip items, right? So you can skip those, okay? But also, as you walk through the lecture slides, know like they're conceptual understanding questions, right? And they are more like computational questions. Okay, those you can see right in the lecture slides. We have some of those are just reasoning. We'll talk about like why it is this way, but they're also examples, right, showing how we do different particular calculations. Okay, and then in the homework questions, okay, similarly, right. Hopefully that gives you a sense of the kind of questions, right, we're asking you. Okay, and today, yeah, the midterm exam. This is the exact exam I gave 2 years ago, right. So that of course will give you a sense of the type of questions you get asked, and also what kind of concepts, right, content you will be tested on, okay? So if you look at, right, overview, right, so first one, true or false questions, and then brief answers, correlation, frequent item sets, classification, class 3. So by now you can proceed, right? This is really the main, like, concepts I want you to understand, okay? And also just relate back to the, like, partial credit, yes, right? All of those, right? So make sure you show enough, okay? That doesn't mean, like this actually, particularly if you look at the exam, in the brief answers, true, false, we specifically ask that you don't need to write long paragraphs, okay? If you're finding yourself writing long paragraphs, that's probably not right, because we don't need long paragraphs, okay? Just make sure you hit the key points, right, for those questions, all right? Okay? So let's go through this. First one, right, true or false, and then briefly explain why, okay? So those are like a 5 point each for questions. So we do, I think what we do was like 2 points for the true or false determination, then 3 points for the actual explanation, okay? So just make sure you write out, right? What do you think is the key answer to explain your decision? Okay, first one, scatter plot, okay? So the question says, the statement, a scatter plot can only show positive correlation between two variables. Okay, so this is basic testing, right? What is scatter plot? We did that in our homework. Okay, scatter plot shows two variables, x and y, right? You see the dots in this 2D space. Okay, once you have these dots, then you can see potential relationship. Okay, what can you see when you have these dots? Like say correlation basically means that you have positive or negative correlations. That means as one variable is increasing, the other variable is increasing or decreasing, right? There's corresponding relationship, okay? So in this case, true or false? False. It is showing two variables, right? But it says it can only show positive, but you can actually also see negative correlation or no correlation, okay? So that's basically the main thing you need to address, right? False, a scatter plot shows two variables as x or y. It can show positive, negative, or no correlations, okay? Next one. Range, this is the function, right? So of this item set is both monotonic and anti-monotonic, okay? So range, of course, is defined by the range like between the value between max and min, right? Okay. And then we're talking about like when you have an item set, you look at the item price within the item set, then you look at the price range, basically, right? And to see whether it's monotonic or anti-monotonic. Okay. So in this question, of course, like we're testing the idea or this notion of monotonic or anti-monotonic. Okay. Monotonic. Basically said if the item set S satisfies, superset also satisfy. Anti-monotonic says if S violates, the superset would also violate. Okay? So actually just had this, right, in our homework questions. So what you need to show is that you do the reasoning, right? Whether you can, like say, show that it's guaranteed, right, to satisfy or guaranteed to violate. That's what we are trying to get to. Okay? So in this case, what's the decision, true or false? 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 Okay. Is it monotonic? Is it anti-monotonic? No. Okay. So you just need to show the reasoning. Okay. So in our case, it's a little bit long, but really just need to follow, right, the procedure. Okay. So starting point, right? So we say, okay, so false. We say, in this case, right, we actually didn't show it's anti because if we say it's a false, we just need to show why it's a false, right? But you can also do the reasoning about why it's monotonic, okay? But here we say anti-monotonicity basically says that if S violates, then the superset would also violate, right? That's the definition, okay? So in our case, right, so we know that the range, so this is actually about the property of the range, right? Range means what? So it's the min and the max, okay? So when you add a new value, right, if it's within the set, your range doesn't change. If it's outside, either smaller or bigger, your range would increase, right? So your range would always increase. So that's the property we're using here, right? So the range of the superset would be at least the same, right, as the range of the S, okay? So now if you say right now anti-monotonicity says that S violates, so that means this the current S, the range is less than V, violates, right? But then because my range would increase, right? So even though currently it violates, I cannot guarantee the superset would also violate, okay? So this is the example why I say like this is not anti-monotonic, and that's why it's false, okay? But let's do a little bit extra, right? So you don't have to write it for this one though, right? But let's say monotonic. So we see that it's actually monotonic. Monotonic means what? So if S satisfies, right, the superset would also satisfy, okay? So in this case, right, if S satisfies, that means the range is at least V, okay? Same thing, right? If this is already at least V, then the superset, the range would only be bigger or at least that value, right? So my superset is guaranteed to be also at least V, okay? So in this case, it is monotonic, but not anti-monotonic. Question?
Can you explain what convertible is?
Okay, yes, right. So we didn't ask this one, but we just had the question, right, about convertible. Okay, so the idea about convertible is based on whether you can, if you control the ordering of your items, then you can make a constraint, right? Because some of those like properties, right? If you don't control the ordering, like you cannot guarantee the order, like the direction to be going. Let's use range as an example, okay? With the range, we say that range would only increase, right? Range will not decrease. Okay, but if my rule says that like this is a like let me see, I think it's this one. Let's say actually we need to switch it, right? If we say the rule says the range is at most V, okay. So if the range is at most V, so if say currently, right, it is within V, okay. Say V is say 100, okay. Now say but my range can grow, right? So if I say the current is less than V, less or equal to V, but then I cannot guarantee the superset would also be less than or equal to V, right? So that's all I said, right? This is actually, it is let me see. Let me do it the other way. So it is not monotonic. Okay, let me actually write it out. It's probably easier to, let me find it. So we're basically switching the direction of that, the rule. Okay, so we say the range of S. Okay, I'm just skipping the price part. So this one says that at most V. Let's say if it's well, at least V. So if you say my rule is this, at most V, okay? So this one is not monotonic because if currently you're less than V, but my range can grow, right? So that means later it may be bigger than V. So that means it doesn't satisfy the monotonic rule or property. But we can make it like convertible. We can convert it into a monotonic rule by enforcing some ordering, okay? So the range basically says that actually the range may not be the best example. Let me think about it. So if it's a range, and if I'm increasing, no, range actually is not the wrong. I should use, because the range, even with ordering, I cannot control. Let me think about it. Yeah, range I cannot, because with range, this is the mean, max. I may still, even if this way, I can still increase, or I can increase on this side. Range actually may not be the one, sorry. Let's change it to another one. Okay, the easiest one is actually we did is this one, average, right? Average, we know the property is that average can only, average can go up and down, depending on how you're adding your items, right? But if I sort my items in ascending or descending order, then my average would only go up or go down, right? So that is the sorry. Okay, so if it's only average, it can go up and down. But if it's like ascending order or descending order, then I can guarantee it'll only go one direction, okay? Now, if my average is this one, right? So if my property says the average is less than, at most V, okay? So then we say, okay, if it's a monotonic, if we say, okay, it's not a monotonic because I cannot guarantee, right? Because if it's satisfied right now, it may change depending on however it's going. But if we say, if it's monotonic, we say, okay, it is at most V, that means if I go this way, right? So if it's already at this point, that is less than V, and it can only go down, then I can guarantee, so if we say this is S, and this is the superset. Sorry, people on that side may not be able to see it. So what we're trying to say is that with average, once I sort the items in a particular order, then I can control the average will only go in that direction. Make sense? And that is how I can guarantee from S to S plus, the superset, it will only go in that direction. This is the convertible, meaning that if I don't control the ordering, the value will go, there's no, I don't have a guaranteed direction for the value to go, okay? But once I can sort it, then I can control the direction. That then it becomes a particular rule that I can use. Make sense? Average in particular is actually interesting because originally it can go either way. So that means I can actually make it, I can sort it in ascending order, so it will go upwards, or descending, it will only go downwards, right? That's actually why average can actually become strongly convertible, meaning that I can convert in both directions, okay? But we had the example, the question in the homework, it's max, right? Max has what property? Max means that if you don't control the order, you would only increase, right? Okay, but so that means I can really make it, how to say, become smaller, because once you reach a particular point, you have a max value, you can only go upper. But I have a way of still controlling it, meaning that if it's from this point on, it's always a downward. That means if you add this point, then after that, even though I say you cannot you cannot go bigger, but you always at this point, because that's the max value. Make sense? So max is something like this, right? You'll be increasing, and then you'll be flattened, right? So if this is your V, say like at most V, then you can still guarantee it'll be at most V, because this way your value will be going down, but your max value will stay at that value. Make sense? What about a mean? Mean can only go down, right? So if you say mean can only go down, so now you can say, okay, if I put it as ascending order, right? Once you add a particular mean, you will only then you basically you'll stay flat at that mean value. Because if the item R value can only go up, now your mean value cannot change. Make sense? So, okay, so originally we say that mean can only go down. If it keep going down, then I cannot guarantee. But if I have a way of saying the value can only be like increasing, so once you have this mean, and this is a flat, so this is your mean value that you can guarantee. Make sense? Okay, so the high-level idea is that without ordering, you cannot control the direction. So you cannot guarantee your superset would either satisfy or violate that property. But once you have a way of sorting it, either ascending or descending, and with the property of your function, then you say, okay, it will be guaranteed to be either flat or keep going up or down. Make sense? All right. Okay, so this is basically the constraint base, right? So you say monotonic, anti-monotonic, and convertible. Next one, decision tree. Okay, so we talk quite a bit, right, about decision tree. We talk about both the conceptual understanding. What is a decision tree? What kind of properties? We also had the concrete examples, right? You need to show how you construct decision tree. Okay, here is about a property. Okay, so the statement says that decision tree induction method cannot support incremental data. Okay, so first you need to understand what is decision tree, right? How the method works. The second one, when we say support incremental data, what do we mean, right? So incremental basis says that when you have new data, right, do you need to redo the whole thing? Or can you take what you already have constructed and just update it? Okay, so if you had a decision tree, right, you say you have, say, for example, like you have some sample data, you construct your decision tree, you're done, okay? And now you have more data. Okay, so the question is, how do you update? Can you update the tree without reconstructing, or actually do you have to start from scratch? Okay, so we did this calculation, right? So if you remember how we did the decision tree construction, you basically do this layer by layer, right? But at each layer, what you're trying to do is that you need to look at, right? You do the attribute selection, okay? Like which attribute you want to select by computing like information gain ratio, so that you have a way to say this attribute is the most informative to help me to separate, right, the different classes, okay? But once you're done with that level, when you go down to the next level, right, you basically redo the process with the updated data set. So if you have a new data set, right, not more data, so you have the original data, you did your calculation, say, okay, say like what was the highlight example? Collector, right? Collector was the most informative attribute, okay? But now you have more data, so that means with the more data, the distribution may be different, so the same attribute, right, may not give you the same information gain, and it may not be the best for that first level. So you basically have to redo everything, because you basically have to reconstruct the tree by computing, right? For this attribute value, for this branch, what is the new information, so that you can figure out the gain. So to answer this question, this is basically what I need to say, okay? Yes, it is true, because the decision tree induction method cannot support incremental data, okay? the reasoning, right? So we say that this is a method, right? It's a top-down approach, chooses at each level the attribute to use, and the data split by branches, right? So when new data are added, we need to redo the whole process, right? From the top level. So that basically means that whatever you have a construct already with the new data may not be usable. So you have to start from the top, redo the computation, and now you're branching, or the attribute you select may be different at each level. Okay? So related to that, can you, there's another method we'll talk about that is actually supports incremental data. Another classification method? Which one? Bayes, right? Bayesian classification, because it's about probability, right? So Bayesian classification works by computing the probability, okay? And the way to compute the probability is that when you have, say, the original data, you computed the different probabilities, and now you have the new data, you don't need to go back and recheck the original data, right? You just need to update your probabilities, okay? So this is the part about incremental data, right? And also the part about decision tree versus Bayesian classification. All right, one more. The k-mean clustering method cannot identify clusters of arbitrary shapes. Okay, so this is something we covered, right, in the cluster analysis section. So the idea is that when you do clusters, right, you basically you're grouping objects, right? The idea is that the objects will be similar to each other within the cluster, different to each other across clusters. But the shape of the cluster, right, depending on your application scenarios, right? We have shown examples about a bit more like circular shape, like kind of nice Gaussian distribution. So it's more like a nice rounded shape versus some of those, I think, like chameleon, like we're doing some of those like clustering where you see very different shapes, right? So the question here is that whether k-means, right, can support arbitrary shapes, okay? So the notion is that, how does k-mean work? K-means clustering, start with k, right, centroids. Every time you're assigning your points to the nearest centroid, okay? So the way you assign it, as you can think about, right, we had this example like donut shape, right? If you say donuts, you have the inner circle and the outer circle. In that case, k-means that doesn't work, because you would have something that is closer to the inner circle, but actually belongs to the outer circle, right? Okay, so that's the high-level thing. So in this one, we say, right, it's true because k-means cannot identify arbitrary shaped clusters, okay? Because the reasoning, right, because the k-means method assigns each object to the nearest centroid. As such, it can only identify clusters of convex shapes, because you need to, whatever like in your cluster need to be the nearest, like closest. This should be the centroid to the closest one, okay? Can you name another method that can deal with the arbitrary shapes? Anyone? Like we had this method where you basically look at the density in your neighborhood, dB scan, right? So dB scan works by looking at the density of your neighborhood, and you try to grow your neighborhood as long as you're dense. So that one doesn't control, right, which direction you're going, okay? So as a result, right, so that method can actually work with arbitrary shapes, okay? All right, so these are the four, like I say, like sub-questions for the true and false, okay? As you can see, right, make sure you state true or false, and then have a brief explanation, okay? You really don't need to write long paragraphs. Just say like a few sentences tops, right? Even though I think the monotonic anti-monotonic, that was part of the one longest, but others, once you get the like key point, it's really a couple of sentences, okay? All right, moving on, brief answers, okay? So these are still like where you say provide a brief answer, same thing, right? We're not expecting long answers, okay? So make sure you just hit the point, okay? First one, what are the 4 different views of data mining? Hopefully by now you all know. Come on, 4. Data, knowledge, method, application, okay? So not just memorize it. I hope you understand, right, why we did have those 4 views. Because just every time you're trying to describe our data mining project, right, talk about those 4 aspects, okay? So just make sure, right, those are simple ones, okay? Next one. What are the main steps in the data mining pipeline? Remember our visual illustration? Starting with, you have the raw data, right? So you have some data understanding, because basically just like characteristics of your data. Pre-processing, data warehousing, right? And then you do the modeling, okay? And then you do the evaluation, okay? All right. Identify 3 differences between OLTP, which is online transaction support, and OLAP, online analytical processing. Okay, so we talk about, right, when we have like a data warehouse, right, it's basically dedicated for decision support instead of like runtime operational support. Okay, so we had this table. Okay, you don't need to memorize the table, but hopefully at least you can do some reasoning, right, about how it's different, because it's just very different usage scenarios, right? One's for decision support, one's for operational support. Okay, because of that, right, you can think about the like online transaction processing. So it's for daily operation, right? So then it's working with current data. Okay. It's for real-time processing, and also like usually you have the like in-place update, because you're updating the current status, right? We also talk about like the size of the data, right? They're usually looking at like smaller, but the current one, right? In comparison, okay, online analytical processing, because this is for decision support, right? So now your users are different, right? So users are usually like say data scientists or like people who are actually trying to pull insights, okay, from the data, okay? They usually work with larger data sets, right? We talk about like historical data, okay? We also talk about like the size is different, processing time is different. This long volatile is another one we highlight, because when you're trying to pull insights from your data, right? So you're not trying to, so basically you want to keep what you have and keep the intermediate results instead of writing in place, okay? So those are just a few things, right? Let's say you only need to list the 3. So as I said, like if you look at that, the table have shown, right? It's not about memorizing, but you see those are the different aspects, how they could be different. So you can like hit again the keywords related to the differences. All right, next one. Name the 2 types of ensemble methods and explain the key difference. Hopefully this would be, again, something like that kind of come to your mind quickly. We don't need to write many words, right? Ensemble is what? Ensemble is about taking multiple class files, right? So when you're building a model, you're not building just one, you're building multiple models, okay? So that you can take the multiple models as a whole when you're trying to make a decision, right? But when you have multiple models, like you can weigh them differently. That's really the main thing, right? What are the 2 approaches? When you weigh them equally, bagging, bursting, right? Bagging versus boosting, right? Equal weight versus like different weights, okay? So that's really the main thing, right? So bagging is equal weight when combining multiple models, and the boosting is different weights for different models, okay? All right, so hopefully like question 1, question 2, right? Those are really like a way of asking really some of like the conceptual understanding questions, right? So as you're going through the slides, like when you mention something on the slide, just say like whether you can do some reasoning, okay? Some random examples. We'll talk about the materialization, right, of the date cubes. Remember? Partial materialization, full materialization, right? No materialization, right? We're talking about like what do you do offline, what do you do online, okay? Related to that, we'll talk about the lazy learning, eager learning, right? What's the difference, okay? So those are the things, right? This is just showing examples, right? As you go through the slides, just kind of identify some of those questions, right? Basically just say it's about your conceptual understanding. You can do some reasoning about the properties, okay? Another one, so you say like interestedness of patterns. Anybody remember? How do you claim your patterns are interesting? Anybody? Your pattern, if you say, okay, I found something, right? So like I went through my data mining process, I found some patterns. I'm now claiming those patterns are interesting. what would you check first? Valid. The pattern need to be valid, right? What else? Novel. It's a new knowledge, right? Okay. Potentially useful, right? This again connecting to like why we want to even do it, okay? And explainable, okay? So those are like again, like those are the things, right? One should just like consider as you're kind of going through those like conceptual understanding aspects. Okay, moving on. And then we're going to see like quite a bit of like more like computational ones, okay? So if you look at those ones, you can see, right, you have seen this, right, in the lecture slides, in the homework questions, and now in this, right? So hopefully by now, right, you are familiar with the process, okay? So if you understand how it's done and you can actually just practice doing this, I think it should be fine, okay? But a few things to note, right? One, show your steps, okay? That's very important, right? As I said, like we're not asking you to do the full computation, right? We said like no calculators, you don't need to write out the final answers, but you really need to show how you're doing it, okay? So make sure, right, you show the steps. Second, double check, okay? This is probably a simple like a table, but later on when you see the training tables, right, you probably all did this, right? For the a priori algorithm, for the like classification, some of you made mistakes just because you either didn't count it correctly or just missed something, okay? So those are the things like just pay attention to, right? Double check, okay? And then well, I mentioned that, right? You don't need to do the final calculation, okay? But don't just give me a formula because we're already providing you with a formula, right? You're not doing the final calculation, but you need to show me how you put in the values to do the final calculation. Okay? So we have some example, just pay close attention to, right? So one, know how this works, okay? Second, right, make sure you write out your steps. Third, double check your answers. Okay, all right, so first one, correlation, right? So we have been talking about correlation quite a bit. We'll talk about different metrics. So this one, right, by now, hopefully you know how to read this. Right? So this is a table just showing like, okay, in my population, I have people like biking, skiing. So those are just the binary, right, scenarios, okay? And now we're trying to compute, right, the lift value. Okay, so the lift value is provided, right? The formula is there, okay? What you look at is that, I think actually, yeah. So lift value chi-square, so these are the two metrics, right, we typically use when you're computing correlation between categorical values, right, variables, okay? So you basically need to follow that, right? First thing, when you're reading this table properly, you understand how you actually take the, like, add up, right, by row, by column. What does it mean, right? So at the beginning, right, those 4 values basically are the 4 combination cases, right? Biking or not, skiing or not, okay? Now you basically say, okay, the 300 means that I have, like, among my total population, 300 of them biking and skiing, right? So now if you want to look at people like say biking versus not biking, so that basically you add up by row, so that's 500, 500. But also if you do the column, right, then you say these are the people skiing, so that's 570, and also not skiing, 430. So this value total, so either you add by this by the rows or by the columns, you would always get 1,000. That's your total. That's n, right? Okay. So now when you're doing the lift, with the lift value, this is important, right? We actually talked about this a few times, just make sure you understand. So here we are using A and B as item sets, okay? So with item set, right, the formula says A union B, right? A union B means that it's a union of 2 sets. Okay, so these are the attributes in a way, right? So think about the items. If you're say purchasing like in your transactions, you're purchasing many books, right? So A would be say the books on like some kind of fiction books, and B would be some I would say like travel related books, right? So when you say A union B, that's about all those books being purchased. Okay, so it's a union. Okay, so in this case, A union B, so that basically means that both A and B will be occurring. So that is the biking and skiing. So that's why it's 300, right? 300, but it's a probability, so you need to divide it by n. Similarly, now you say people biking versus the people skiing. So then that's the 500 divided by 1,000, 570, this one by 1,000. Clear? Okay? So the calculation is like, once you write it this way, you don't have to show the final result. Just you need to write out, right? Write out the formula, write out like when you fill in those numbers, right? So that we show that like we are using the correct numbers for the calculation. Okay, next one, chi-square analysis, right? Same thing, right? You have the formula. You just need to know, write out, right? How you do the expected values and how you do the overall chi-square calculation. Okay, so make sure you fill all this in. Okay. So I'm just kind of using a simple notation here. So here, this is the expected value for both being true, right? So both showing up. So that means the biking and the skiing. So that means it's this one. So it's this. So biking. So that's 500, and then skiing. That's 570 divided by the total of n. So that's 1,000. Okay. I'm simplifying this, but please, you need to write out this for your actual answer. Okay. So just make sure you write out the expected value, how you calculate the expected value, right, for each of these like scenarios, okay? Once you have that, right, now you need to fill this in because you have basically the chi-square calculation is the sum of the square difference of the observed value and the expected value. Okay, so it's okay you write it like this, okay? Because once you have this defined, you can write it this way. That's okay, but you need to write out the other like aspects, right? The expected value, so that's a 300. Oh, sorry, observed value is 300, and then minus the expected value raised to the power of 2 divided by the expected value, and then write all this out. Okay. But there's one more, right? Because you're not doing the actual calculation, but we're now asking you, right? Because once you have computed the values, you need to show how you make a decision, because ultimately the question is about whether there's correlation or not, right? And whether it's a positive or negative correlation, okay? So just know that, right? What those measures mean, like you know how to compute it, but also you know what they mean, okay? But this one, right? This is related to the now invariant or now transactions, okay? So now transaction are basically, like going back to the previous table, we're basically talking about this case, right? This is like none of that is happening, okay? So I'll quickly go through, right? So this question, let's say, just weigh whether they are now invariant or not, and then briefly explain why, okay? So for this case, right, what you're looking for is that whether this formula in your calculation, do you consider this now case? Right, 0, 0, like not biking and not skiing. Is that considered or not, right? Okay, so in our case, right, we basically say, okay, now invariant metric, right? So that basically means that metric is not impacted by the now transactions, i.e. not biking and not skiing. But if you look at our formula, right, for calculating lift and chi-square, they do consider those, right? Chi-square spread out, right? The expected value of the 0, 0 cases, right? That's the not skiing, not biking scenarios, okay? And then for the lift value, the probability of skiing or probability of biking, they actually consider the scenario of them not occurring. So that means that you do have that 230, that value being considered in your calculations, okay? Yes?
So it has nothing to do with like actually like how it processes the null values, but instead how it processes the non-occurrence values?
Okay, let me try to. So you're asking we're talking about the now transactions, right? So now transactions meaning that if none of them happened, not biking, not skiing. That's the scenario we're talking about.
Not like a null value inside of those.
Yeah, so it's not a null value. Yeah, okay, so yeah. So when we say now invariant or now transaction, it's not about like a null value because, well, here we're talking about categorical values, right? We're basically talking about whether they occur or not to some extent, okay? So in this case, right, so the now transaction or now invariant means that whether they consider the scenario of those items, right? Those items just don't occur, okay? I keep using the example of, say, like Amazon, right? Amazon has millions of items. But when you're trying to look at whether, say, like fiction books and the travel-related books are related or not, you look at those books being purchased, right, at least by one of the scenarios. but you don't care about the many cases where none of those books, like neither the fiction books or the travel books are purchased, because that will be dominating, right? There may be many, many cases, many transactions that doesn't contain any of those cases that you care about. Make sense? There was a question? Yes.
Can you explain why?
I'm sorry?
Can you explain why Lyft doesn't factor in again?
Okay, yeah. So the question is why Lyft, right, is not now invariant. I think I have the formula. If you look at the formula of the Lyft, okay, let me go here. I don't have the okay. Okay, so this is the calculation of Lyft, right? Okay, so if you look at the formula, it's the probability of A union B, A and B occurring together, and the individual probability of A and the individual probability of B, right? So the main thing is that whether this cell, this value, is being considered or not. Okay? For you to compute, right, these probabilities, you have this 1,000, right? 1,000 is the total population. That means this 230 is being considered. Make sense? Right? So if you look at if you go to the slides, right, we had a few other cases, right? Those actually only consider the other ones. They don't take into this cell into consideration. Okay? So that's why Lyft chi-square, they are using, right, this value. Because in this case, the total of 1,000 is including those transactions or those cases. Make sense? All right? Okay. So one, right, computational steps, knowing how to use the formulas to do the computation. But then in terms of understanding, right, once you have computed, you can decide, all right, whether there's a correlation or not, whether this is a positive or negative correlation, right, and whether it is now invariant or not.
So chi-squared and Lyft, do they always take into account the wall?
Yes, yeah. So yeah, chi-square, Lyft, they are, so as we have said, right, so for example, let me actually show one more. Yeah, chi-square specifically, because chi-square is doing this difference between the observed value and expected value for all the 4 scenarios, right? So this is a clear including of this now transaction, right? Lyft, because I'm considering everybody, so that is also including the now transactions, okay? All right, so related to that, right, once I've computed the Lyft value, how do I determine whether it's correlated or not? There are a few cases, right? Positive. When do I say it's a positive? Greater than 1, right? Because the probability of them happening together is bigger than the probability of happening independently, right? So when you have computed Lyft value, say if it's greater than 1, it's a positive correlation. Equal to 0, no correlation. Less than 1, equal to 1. Equal to 1 is independent, and then less than 1 is negative correlation. What about chi-square? Chi-square would say the value need to be big enough. When it's big enough, they say it's correlated. But by that, it doesn't tell me whether it's a positive or negative. How do I know whether it's a positive correlation or negative correlation with a chi-square value? Because this is squared value, right? So it will be a non-negative value anyway for the chi-square value. But this is the comparison, right? Because we're talking about the observed value and the expected value, right? So if the observed value is higher than the expected value, so that means expected value means that if I assume they are independent, this is the number of instances I would see, right? But if I have an observed value that's higher than the expected value, that means they're more likely to happen. Make sense? So that is the positive correlation you can infer when you're doing the chi-square analysis. Clear? All right. Okay, next one, so moving on. So you kind of see the sequence, right? Talk about frequent about correlations, and then we'll talk about frequent patterns, okay? So these are some standard, right, computational steps, right? So how do you take this table, right? This is a transaction table, right? And find the frequent item sets, okay? So we had this in the lecture, in the homework, okay? Hopefully, the computation-wise, you kind of know the process, right? Prairie algorithm and also the FP growth, but some of the conceptual understanding, right? We talk about well, actually, let me show this out first, okay? First one, right? Support. What do you mean by support, right? Support is basically how frequent, right? How many times you need to see this item set, okay? So the first thing you take is that, okay, I have, say, for example, I have 10 transactions, right? If my minimum support is 45%, so I need 4.5 occurrences, okay? You need to round up, right? So you can only do, like, say, at least 5 occurrences for you to consider this as a frequent item or item set, right? Okay? So with a priori algorithm, right? So priori algorithm have this kind of iterative process, right? First scan, you find the frequent 1 item sets. Then you generate the candidate 2 item sets, right? Another scan to find the frequent 2 item sets. So basically, you iterate that process. So in our homework question, right, we will ask you what's the maximum number of scans, like number of scans, maximum number of candidates, and also we also did the complexity calculation, right? Candidates versus the actual frequent item sets, okay? So by now, hopefully, you know how to do it, right? So the process is simple, right, in a way, but again, make sure you double check your answers, right? In those kind of cases, even though we try to minimize the number of transactions, the items, but still you need some checking, right, to calculate the frequency, okay? So once you have that, right, so make sure you write, again, show your steps, right? You say, okay, I start with my first round. I'm trying to find the 1 item sets, right? So I find the ones that are like frequent, and then the ones that are below 5, those are infrequent. So you can either cross out or just say those are infrequent. So those are my frequent ones, right? And then show specifically, right? Say, okay, with that, I can generate my candidates, okay? So I have those ones, right? And then we'll say, again, same thing, right? You need to make another scan to remove the ones that are not frequent. Okay, and then with that, right, you continue, okay? So in this case, right, this is actually some of the specific we're showing, right? So when you're generating your candidates, right, you need to check whether that is a valid candidate or not, right? So in this case, right, I have FZ and TZ, but I cannot take FZ and TZ to generate FTZ as a candidate. Why? I'm missing FT, right? FT is not frequent, so that means FTZ cannot be a frequent candidate, okay? Similarly, right, you can say I cannot take a TZ, XZ together because, again, T and X is not frequent, okay? So that's also, again, something like when you're kind of rushing, you may miss that step, right? So a few things to keep in mind. One, start by saying that, okay, given the minimal support threshold, right, how many occurrences I would need to see, so that's your first round, right, the first thing. And now, as you go through the steps, right, always show this is the candidate. These are the ones that are removed because they're not frequent. Okay, this is the actual frequent like K item sets, and then this is how I generated the next round of candidates, and make sure you check whether the candidates are valid or not. Make sense? Okay. Then. I think this is the one. Related to this, right, we had some discussion, but I think I got a few questions about like closure pattern, max pattern, right? How you do this like K choosing or N choosing 5, whatever, right? So the whole high-level idea is that you are looking at like some combinations, right, of your items, okay? And those combinations, right, when you know how many items you have, you can try all the possible combinations. But if you know that you only have certain number of items in any transaction, right, you don't need to go up all the way to all the possible combinations, okay? And then another thing, closure pattern versus a max pattern, okay? Both are trying to find the largest pattern, right? The only difference is that closure pattern maintains the same support value. Max pattern is say, as long as you're frequent, as long as you're above my threshold, right, I'm good. So that means if you see our example in class, right, the closure pattern, we're actually keeping 2 because they have different values, different support values. While for the max pattern, we combine it because once they're both frequent, this bigger superset is all we need to keep for the max pattern. Okay? All right, so just make sure you review that as you're kind of talking about, because ultimately with the frequent pattern mining is that you want to find the largest pattern that is frequent, okay? And relate that, right, the a priori property, why we can do the filtering, because if the smaller item set is not frequent, anything containing it, any superset of this item set cannot be frequent. So that is a property we're trying to leverage, okay? All right, so moving forward, right, so we're going to talk about the other approach, okay? So this is a required concept or understanding for graduate section, optional or extra credit for undergraduate section, right? So FP tree, okay? Make sure you know how to do it, okay? So at the high level, right, FP tree, you still do the first round. First round is the same, right? You need to at least scan your database once, okay? So first round, you get the unique ones, identify the ones that are not frequent, so remove them, but now you sort by frequency, okay? So this is important, right? Yes? Yes, yeah. So in the homework, yeah, for that particular case, right, you actually have, like, because we say we sort by frequency, right? So usually if you have, say, 2 or multiple items with the same frequency, typically we would just do alphabetical order, okay? So let's just do that. I know in this homework, some of you did a different ordering. We're still trying to, like, give you credits, right? It just makes ours, like, our grader job harder if we're trying all the combinations. So let's just make it consistent, okay? If you have the same frequency, right, meaning the order really doesn't matter. Let's just enforce one order, alphabetical. Fine? Okay, all right, yes. So once you have that, right, so you say I ordered, and in this case, right, I have fx, so f goes first, just alphabetical, right? And now you need to get, so when you're drawing, right, the FP tree, make sure you have the support values, the node links out, okay? So here I'll just show, like, just write out, because well, actually, if you do this in paper, you actually draw the tree if it's easier for you, okay? If you're doing this online, right, if you want to just write it, you can use this notation. This is the one we asked you to use for the homework as well, okay? Basically, you just need to know, you need to show the relationships, right? The parent-child relationship and also the linked list, okay? So at a high level, right, if you're just doing this, right, make sure you write out, right, so like for each level, right, this is the parent, this is the root node, and then make sure you put the support values in, okay? Because they should add up, right, to the total frequency you have for each item, okay? So that is once, as you're doing this, make sure you write all this out, but also make sure you don't miss this part, because we had the header table, remember, right? Header table is for the individual items, because that is how you can quickly identify in the big tree, right, where you have those items, those particular items occurring in your tree. Because once you have those items, you do this like backward, like traverse to generate your patterns, okay? So just make sure, right, undergraduate, like if you're in the graduate section, right, make sure you understand how this works. Undergraduate, if you want to do, like, get some extra points, this is also, I think it's reasonably, right, like helpful to understand and see how it works, okay? So I just write out the answer, right? So you can check. If you have any questions, of course, you can follow up. But this is how we expect you to make sure, like, show, as I said, like, first do the sorting, right, of the transaction based on the frequency. And then when you're drawing the tree, make sure you have the tree, the links, and make sure you have the node links. That's the horizontal links. We're trying to connect the individual items. Okay? Any questions? Yes?
Sorry, just to clarify, so from the ordered item set, you leave out anything that is infrequent?
That's right, yeah. Okay. Same thing, right? This is actually the same thing for both a priori and FP tree, because if it's infrequent, I don't need to consider it. Because anything considering, like, including, containing the infrequent ones cannot be frequent. So I can, or like, say, just ignore that altogether, okay? But it's another thing, right? Between FP tree and a priori algorithm generates candidates, right? And then count the support value, then remove the candidates that are not frequent, okay? With FP tree, with our tree structure, it's a prefix tree, when we generate the patterns, they're guaranteed to be frequent, okay? All right, going forward, classification. So that's the next, right, big chapter, actually 2 chapters. So by now, right, for first you need to know how to read a table, right, training table, okay? With your training table, you look at which are the attributes, okay? But just know that the class, which column is the class label, okay? Because that can be different, right? So make sure, right, using the same table. I don't have it. It's on the next slide, okay? So one, knowing how to read the transaction table. Training table for classification, and make sure you check which column the class label is, okay? And then, like, so here, right, this is a decision tree induction, right? So we had the examples, right? Basically, you just need to show how you use the decision tree induction method to construct, right? We usually ask you just to do the first level, so you don't need to worry about too many, because repetitive, right? Once you can show you can do it for one level, you're good, okay? So make sure just to say how you actually then, how you do it, right? So here we say, if you read this, right, one, right, write out the steps for computing the information gain for the temp attribute. So you only do this for one attribute, okay? Just to show how you, like, look at the values, how you do the branching, how you split, like, identify the class label distribution, right, within those branches, and write out the computation. Okay, you have the formula, you just need to plug in, right, the different numbers, okay? Also, we're asking this question, right? Given the information gain value of two attributes, do we select the attribute with a higher information gain or lower information gain? Briefly explain why. Okay, so this is all about decision tree, right? How you do it, but also the reasoning, okay? So this is the table, right? As I said, right, for here we say picnic, but I could be, like, say, choosing, let's say, if you say my class label is being windy or not, right? Make sure you read the instructions, right? So giving the table, which column is the class label and which columns are the attributes. Okay, so first we'll say, okay, picnic, we have two, right, classes, yes or no. First, of course, I need to spell out, right, the distribution, right? At a high level, I have 14 instances, I have a 9-5 split. 9 of them says picnic, 5 of them says no. Okay, so that's my, like, initial data set, but now if I'm using temperature, right, to do the branching. Okay, so temperature have 3 possible values, like hot, mild, cool. So you basically, you're taking the 14 cases, split them into, that's your branching, right? 4, so they should add up to 14. And for each branch, you're looking at the class distribution. Okay, so you need to kind of basically write out something like this, right? So that's say, okay, I'm using, so this is the overall distribution. Now with the branching, I have those branches, and this is for each branch what distribution have. So once you have that, right, now you just need to write out how you do it. What is the first one, information gain, right? So we need to see this level of work, okay? Don't need to do the final calculation, but you need to write out, right? So this is how I'm doing the information for the whole data set. And then I'm doing the temperature, right? Because this is how I need to write this for the individual branches and then weight the sum. So we are using this. It's okay you use this notation, okay? But make sure at least you do it once, right? So you see, like, we know how you know how to do the information calculation, okay? And then once you have that, you're basically looking at the gain, okay? Now we say, okay, we need to choose the one with a high information gain. Why, right? Lower information means pure or more uniform class distribution. So you start with the same, right, information. If you have an attribute that will give you a lower information, so that means the gain is bigger, so that means you have better, right, classification. So high information gain means a larger information reduction and lower information. So you have purer classes after your branching, okay? All right, so we talk about decision tree. Of course, the other one is the Bayes, right? Naive Bayes classification, okay? Same thing, you need to, one, read the table, right? Second, know how the process works, okay? So by now you have seen a few examples, right? Lectures, homeworks, and also this one, okay? Just make sure you know how to plug in, right, the different information. Okay, so here the case is that, okay, I'm provided with this particular instance, right? So I have the attribute values, okay? Now I need to decide whether picnic is yes or no, right? So you basically need to write out, right, the scenarios, okay? So first one, so I give me x, that's the values. So I need to first do the individual class level, right? So it's a 9 out of 14, picnic is yes. For 5 out of 14, no picnic, okay? And then you need to do this, the actual calculation, right? So this is how you use the Bayes theorem, right, to plug in the different attribute values, okay? So the idea is that, okay, if it's x, so giving x, what is the probability that picnic is yes, okay? To do that, you need to write out like this. Similarly, right, so you plug in everything, right? So that's basically now you need to do this one. If it's a yes, what is the probability of x? X now is the individual attribute values here that you need to calculate, okay? And then you can write out this, right? So you can, here of course, you can ignore p of x because we're only selecting the larger one. So you basically just write this out, but it's okay. You say, okay, I'm ignoring p of x. So this is for the yes cases, and similarly, you need to do this for the no cases. It's not synchronized. Okay, so for the no cases, right? Okay, this is actually a scenario where you actually have a 0. Remember, we talked about 0 probability, right? So when you have 0 probability, then just add another note, right? We say that if it's 0 probability, you want to do very small kind of like update, basically just adding 1 to the cases so that you can then have this updated non-zero probability, okay? So that's basically like all the process, right? Make sure, right, one, you identify like what is the class label, and then identify then how you compute the different class, class labels giving x. Write out the steps, plug in the numbers, okay? If you don't see 0, you're fine, you're good. If there's 0, add another note, just saying if it's 0 probability, we need to make adjustment, okay? This is the last one, clustering, okay? So this one we finished, right, just recently, so hopefully you still remember how we do this, right? So in the homework, we actually did this before, it was a 2-dimensional, right? So we're making this slightly easier. This is just only 1-dimensional, but similar idea, right? So we just want you to show how you can do, right, the k-means clustering, okay? So understand how k-means works, right? You start with the k, so that's why I say we're telling you, right, how many like centroids, right? So initial clusters, that's the 50 and the 100. So that's what initial centroid, right? What you need to do is just assign them. Okay, you don't have to sort it, but it's actually a show like it's easy if you sort it, because once you sort it, then it's easier for you to decide, right? A split point, right? All those left side go this way, right hand go that way. Okay, so first just show how you do it. First round, what do you mean? Each round you need to do what? You need to do the assignment, and you need to update the centroids, right? Make sure you show both. Okay. So as I said, with this 1-dimensional, usually it's easy if you just sort your data, because once you sort it, then you can quickly identify which ones goes to which cluster. Okay, so in this case, 50, right? So that's basically, okay, 70 is still closer to 50, but 80 is actually closer to 100. That's where you partition them differently, right? So you need to say, okay, in my first round, I'll say, okay, which data points goes to which cluster. You just need to show, right? And then make sure you update your centroids, okay? Write out the calculation. You don't need to do the final answer, but make sure you have this step of updating the centroid using the points that are assigned to a particular cluster, okay? All right. Next one, okay? Consider the B part. What is the computation complexity of a k-means clustering? Briefly explain why, okay? K-means, right, has a few parameters, okay? So with the k-means, you have k. K is the number of clusters. You have n. N is the number of objects. And then t. T is the number of iterations, because it's an iterative process, okay? So with nkt, right, what do we do? Okay, so we have t iterations. Okay, so in a way that's the outer loop. Okay, within each iteration, what do? You go through each object, right? Because that's a partitioning angle. So you go through each object, trying to assign it into a cluster. But to do that, you need to go through the k centroids, compute the distance, right, and then decide which one is closest. Okay, so if you kind of just quickly think about how you would write this, right? So you have a t as your outer loop, the iteration, and then within that, you go through each object. For each object, you go through the k centroids to decide where it goes, right? And after you're done, you update the centroids. Okay, so you put in this all together, right? So it's really the big O over k and t. Okay, so you need to spell out what do you mean, right? So we have k clusters, I have n objects, I have t iterations. Okay, just explain how you're doing this, right? So that you have a reasonable your reasoning showing the complexity. Okay. All right. I think that this is the last question, and we're done. Let's see. Okay. Okay, so given two different sets of initial centroids, right, does the k-means method always generate the same clustering results when it terminates? Yes or no? No, right? We talk about like k-means, like k-means is a heuristic method, right? Doesn't guarantee global optimal. And the way it works, right, the initial centroids can have a significant impact on how you're partitioning the points, right? So if you get to more like a local maximal, that basically means that, okay, whatever initial centroids you use, that is deterministic. But if you choose a different set of centroids, initial centroids, you may have different clustering results, okay? So that's, again, just an understanding of the method, how it works, right? But also understand the property, okay? So in this case, right, all you need to say is that, yeah, it's not, we cannot guarantee, right, finding the same clusters, okay? Because it is heuristic, it's like with the different centroids, you may actually end up with different clusterings. Okay, so that is all for our, actually let me bring back let me see okay, just a quick reminders, right? So this is going back to this. First, office hours, right? This is where you can still find us quickly. And then the exam time. Okay, make sure you know your schedule when and where how you're going to take it. Okay, if you have any questions, contact us as soon as possible so we have everything planned out. For the exam itself, right, if you're taking this in person, so this is where we're going to do it. Okay, so please try to arrive a few minutes ahead of time so that you can be ready, so you can start promptly on time. So it's basically the 75 minutes for the whole exam time. Any questions? All right, we're good. Okay, we'll see you on Thursday.
Sorry, I had a quick question.
Sure.
For the FP tree,